Welcome, colleagues. Welcome to the SAMPE Technical Committee's webinar on thermoplastic composites from recyclable to recycled. Thank you for joining our SAMPE Technical Committee's webinar today. We're pleased to have you join this webinar on thermoplastic composites from recyclable to recycled. I'll shortly introduce our moderator and our presenter, and we'll go from there. But for now, please enter in the chat. Please enter in the chat your name, your job title, your company name, and your region of the world. Again, please enter those 4 items in the chat. Your name, your job title, your company name, and your geographic part of the world so we can get to know each other. We will be recording this webinar, so a few weeks after its completion, you will receive a link to the full recording. So please don't worry about making notes. We will have all the recording available for you after. It will be available on SAMPE's YouTube channel. Cecile, I'm going to go ahead and pass it over to you so you can start. Thank you so much, everyone, for joining the SAMPE Technical Committee's webinar.
Hi, everyone. Thanks for the quick intro, Raj. So before I introduce today's speaker, I just wanted to briefly introduce myself. So my name is Cecile Grubb, and I serve as the secretary for the SAMPE Technical Committee on Sustainability. I'm also a PhD fellow at Volkswagen in Knoxville, Tennessee, where I'm working for Volkswagen while I do my PhD at the University of Tennessee. And I'm doing work on recycling and manufacturing natural fiber composites. So it's a real privilege to be a part of the discussions like this that are going to drive innovation and sustainability in our field. And with that, it's my pleasure to now introduce our speaker, Hans Luinge. Hans has an impressive background in polymer science and a career that's deeply rooted in the world of composites. So Hans earned his PhD, and after that, he's worked for different OEMs such as Airbus and Suzlon, as well as material manufacturers like Toray Advanced Composites. In 2022, Hans co-founded Spiral Recycled Thermoplastic Composites, or RTC. His work there focuses on developing recycling technologies to support the composites recycling ecosystem and ensure that thermoplastic composites can live up to their potential as sustainable materials. We're really excited to have Hans with us today. And with that, I'm going to pass the microphone over to Hans. And actually, before I do that, feel free as you go to put questions in the Q&A chat, and we'll get to them at the end. So Hans, you can have the mic now.
Thank you, Cecile. Thank you for the introduction. Yeah, and I guess this is we're kicking off the webinar sessions for 2025. So for those who have good resolutions and sustainable is on the top of the list. So it would be good to explore further the common ground and let's share and discuss. And if it's not on the top of the list, that's very understandable as well. But I hope we can show a bit of a pragmatic approach towards a efficient use of resources. Yeah, so it's indeed topic of today is the recycling of thermoplastic composites with a focus on the implementation of it. And indeed, as Cecile says, to live up to the promise of recycling of these materials. Now I'm... So recycling of thermoplastic composites. So it's, as said, it's efficient and widely adopted recycling is part of the sustainability promise for composite materials. And thermoplastic composites and compounds really allow for an efficient and full recyclability. And really retrieving its inherent economic and ecological value. But what we see is that the technology is there, but the implementation is lacking behind somewhat. And this is something we really want to change, and we feel it's a joint responsibility. So we need really to work together with the whole value chain to get this to work. We'll come to that in a bit as well. So maybe first go to the topics. A bit of the background, historical background on where we were and where we are now today. The activities of our companies, which indeed focus also on the supply chain, the impact we can potentially make, and some application technology examples, maybe as a bit of inspiration. So to really go from the collection side on the one hand to the conversion at Spiral, and indeed the commercialization of the application on the other hand. But first, a bit of background of the activity. So where did we come from? Where are we now? And this typically starts with research, then that continues with technology development and demonstration. And if all goes well, then we really need to get it to recurring business. So this is already a picture of a peak preview the recycling technology. So what's new on this topic? I used the slide last year, and then I could say it's a 30-year anniversary of the recycling of thermoplastic composites. Now I had to add a plus to it to 30. So this is a paper from '94, really showing the recycling, basic recycling technology. This is at least the oldest one on these materials I could find. Maybe there's older, then please let me know. But this really makes sure, shows the recycling, and it's really mechanical recycling. So grinding it down and compounding it to a compound, a molding compound. The advantage of thermoplastic composites is obviously that you can both recycle both the fiber and the matrix. So it's not only one of the two, but it's actually retrieving both materials in principle very energy efficient recycling process. So it's a relatively efficient process to retrieve or make new materials from this. And one sentence I want to highlight is the last sentence of the summary. And it says, a simple economic assessment has been performed showing that in principle, the recycling route is viable. And to be honest, if I would write a summary right now, then it would this conclusion still holds. So I think, and we have to take it to the next step. Okay, so this was one of the first, then it further developed, and the first one was on tape materials, on materials recycling. This is on consolidated parts, and it really showed the processing technology for consolidated parts. Again, mechanical recycling, again, molding it into compounds. And also press molding, so really do more composite processes. So that's an addition to the previous paper. Still both relatively short fibers, and then a lot of initiatives also came to look at increasing fiber length. I took this one. I think it's a really nice paper, a nice work. Looking at the recycling and flakes into direct molding compounds. And it's really the fiber length, which is a balance between the processability and the performance. So these were all, let's say, research activity with papers, and then many impressive technology demonstrations followed for these materials. And it's at the bottom of the slide. This list is definitely not extensive, but I think some nice highlights. And the first one is the work done on the eco design multifunctional fuselage demonstrator, who also won the innovation award for the YEC Innovation Award this year. But it's IMEN in Spain really made the clips to hold these stringers and stiffeners to the skin, and I think it's a very nice technology demonstration. Also, a highlight is a TPRC, so the Thermoplastic Research Thermoplastic Composite Research Center, making a hedge from recycled PPS, carbon PPS prepreg. Torre Advanced Composites on the right with a hybrid technology to use the combination of continuous fiber reinforced materials with discontinuous fiber reinforced materials. Also in the clean sky, other clips from Leta, and GKN and Daher making nice flying demonstrators and small series of parts in the recycling arena. So these are really nice examples. A lot of them is project based, and then we come indeed to our activities at Spiral. What we said is, okay, let's bring this from projects to a recurring supply of materials. And what do we need for that, and what are the opportunities to do so? And then the first question is this really a circular supply chain? So if you look at circularity, you typically make these nice circular drawings. And the question is that really the case, especially for these materials, since typically we go from continuous fiber reinforced high-end materials to discontinuous fibers, so it's not the very closed loop recycling. This is also a bit in our name, in the name of our company, and the logo. It's more or less a spiral, an open loop, or something in between recycling. It's the whole aim is to make good use of these materials and use them wisely, let's say. Yeah, so we founded the company in 2022, end of 2022, really to look at, okay, what does it need to bring this to action, and how can we build this supply chain? And that's looking at manufacturing waste, zero waste manufacturing, so to allow for efficient production of both of materials production and components production, to end-of-life material solutions. What we're looking at is mostly the high-end composite materials, for example, the carbon fiber, polyurethane ketones, PPS, nylons, those kind of material, because there's really an ecologic and economic value in these materials. So it's worthwhile to do some effort to retrieve the value. And it's typically in markets for aerospace, automotive, sports, urban air mobility, etc. So what do? We collect the materials, we convert these materials by size reduction, we buffer the materials and supply the recycled materials for new applications. And that can be for injection molding on the right. So that's there's an existing supply chain for that. So that's I would not say easy, but it's the shortest term. 3D manufacturing, and that's typically the extrusion type manufacturing, which is can make use of these materials, and also press forming materials. So we are not doing this alone. So we have we partnered with a company, a compounder company. It's called Whitcomb here in the Netherlands. who is focusing really on this high-end materials. The compounding has a long history in compounding such materials, and that is a very good link in let's say transferring waste into a performant compound, and is really providing a robust supply of these materials. And with that, we believe both we can really fill the gap in the supply chain from, let's say, waste to new applications. So if we look a bit closer to the implementation and the needs and the possibilities, it's probably good to distinguish a bit between production waste or post-industrial waste and end-of-life waste. If you look at these type of markets such as aerospace, the production waste is really typically well-controlled materials, so it needs to be collected in the right way, and that's also something we are supporting with. So each company has its own boundary conditions, let's say, but in principle, the materials are well controlled. However, the volumes per entity are relatively small, so it really doesn't make sense from a business perspective to if everybody starts doing that themselves. That's also why we said let's start an independent entity to really collect these materials to a critical volume to make it also an economic sustainable activity. And the third bullet here is really the matching of the waste volumes and recyclates are challenging. So it's typically companies with the waste often work with continuous fiber reinforced composites and not with the discontinuous compounds. It's, for example, again, aerospace type of materials, and applying these type of recycled materials in aerospace is challenging because of the safety and qualification efforts. So this doesn't always match, and that's also again, okay, we need to combine these volumes, make it generic recyclates to really use it in. Sometimes you can reuse it in the same application, but a lot is open loop recycling, and it can be a hybrid. So, for example, if somebody has 100 kilograms of waste and can use 10 kilograms in their own applications, but still has 90 kilograms to find a solution for it. So that's all kind of scenarios which we are working with. So that's production waste on the one hand. The end of life is a bit more challenging. That has to do with the efficiency of harvesting, the logistics. How do you get the materials together? And that's also a bit dependent on the market. Aerospace has different requirements or different end-of-life logistics than automotive, than consumer goods. So it's all different, and that's something we have to work together to solve that. But also material challenges. So the image which you see here on the screen is from a dismantling of a 777 Boeing 777 aircraft, and there are some thermoplastic composites in these ducts. Well, how do you know it's there? How they can identify it? What does the contamination look like? And you see a lot of foam and Tedlar and appendages in there. So how can you separate these material in an efficient way? Technology-wise, it can be done, but can you make a case for it, and can you really implement it? We feel it can be done, but it's also requiring some design of recycling and again working together in the supply chain. But this is at least something we're looking at. We are developing this together with partners, knowing that it's not a short-term solution, but we are convinced we need a solution together to make this happen, also in the long run. So this is a bit from the waste side, and if we go to, okay, what do we make out of that? That's products, and these are typically carbon based materials, nylon, PEI, PPS, polyaryl ketones. So that's meaning peak, PEG, low melting peak, those kind of materials, and we can convert them in injection molding compounds, and also additive manufacturing compounds for extrusion type of materials. This is obviously short fibers, which is for that reason also a very robust route. The question is, can you maintain the fiber length in a controlled way? And that's something we are also there. The technology is there, but take from a technology to implementation, that's requiring still some questions to be solved. And also we're looking at let's say forged carbon type of materials. So can we make some intermediates for processing and forming that into new products? So these are a bit of the product types we're looking into. Then if you look at, okay, what are we looking into the impact? We'll look a bit into the performance and the ecological impact. And for that, I would like to introduce our tagline, which is high carbon performance and low carbon footprint. So that's the whole aim of our activities. And if you divide that a bit, they can see on the left side the performance, and that's of an injection molding compound of recycled material in yellow, compared to a reference commercial compound of the same material family. And what you can see is that it's as good or sometimes performing even better than the reference material. And that's also looking at the waste source, which is a very controlled material. I would not say maybe it's logical, but it's something which can be explained, let's say. And also because the fiber length in these compounds is typically a bit longer than in commercial reference injection molding compounds. So that's the performance. So maybe summarizing, it's the production waste, well-controlled production waste, turning that with a controlled process, then you end up with controlled molding compounds. On the other hand, the low carbon footprint. Well, we did our LCA estimations, which is the deeper you dive into it, the more questions you get typically. So it's all based on which scenario do you choose, which assumptions do you make, which cutoffs do you have, which databases are you using. So there's a whole world behind it. So we made our estimations, and that's shown in this graph, and I'll talk you through it, and it should give some tendencies. So it's 4 different lines, where the V stands for virgin and the R for recycled, and you have the different combinations for injection molding compounds of different weight percentages. And on the y-axis is the amount of emitted CO2 per material. If you look at a virgin material, the carbon fiber is quite energy intensive to make. So the higher the carbon fiber loading, the more the emitted CO2 emissions increase. On the other hand, if you take the recycled composite materials, these are typically highly fiber loaded, so you have to dilute it to get it into a processable injection molding compound. But then you see that obviously the more virgin peak you add, the more emissions you get. So and that's the yellow line. So improving the or increasing the fiber content will improve your emissions, so decrease your emissions. Then obviously we're also looking at, okay, what happens if you use recycled peak to dilute it? Then that's the almost horizontal curve below. It's looking already better. And then the second and the further recycling, so that's really the recycling without dilution. It's the real pure recycling process of size reduction and recompounding, and that's very minimal. And that's the lowest line. So again, these are all estimations, but I think the trends are there, and it's also showing that well, the recycling process compared to virgin is an order of magnitude smaller in terms of emissions. So let's have a look at the application side, and then first a bit of technology. So we have a project which is called Phoenix. So it's a Dutch word for Phoenix, the English word. So it's phonetically the same. It's a Dutch project where it's really aiming to develop an economic and ecological attractive route for circular material use in aircraft manufacturing industry based on thermoplastic composites. So it's waste-free composite production, and also looking at reuse of high-performance materials at the end of the economic life of aircraft. And also looking at, okay, what do we need to make parts, so the design for and with recycled materials. And that's also including database values, both mechanical database as well as performance database. So this is a project we're doing together with the TPRC, mentioned before. It's a 4-year project, and well, we have interest and support from the large aerospace OEMs, Airbus, Boeing, Embraer, as well as a company called Aircraft End of Life Solutions, looking at recycling of aircraft, which is located close by. So what do we look at? So it's different steps. The first is collect and sort production and end of life waste streams. That's in our focus to do that efficiently. Can we do the size reduction efficiently? And that's also looking at scaling it up. So we learned it the easy and the hard way that the size reduction of a couple of kilograms is different than a couple of tons, and that's so that's what we learned, and solving to make that really an efficient procedure. Then we're looking in indeed, okay, can we compound it to different sorts of the products, including the database, and can we get some design rules to for the design and processing of these materials? And that's mostly in hands of the TPRC. One thing which I would like to highlight is that this is looking at variations in the material and contaminations, but this is focusing on variations. So you have these molding compounds with typically a very controlled fiber length. So the question we ask ourselves, so if you do the recycling, you per definition have a broader distribution of fiber length. what is the influence on the mechanical performance. So we control that in a different way by mixing flakes of different lengths, so mixing different fiber length together in different portions, consolidated material, and did the testing. And that's typically tensile, stress, stiffness, and impact energy. So, okay, what is the influence of fiber length and fiber distribution? And without going into too much detail, what we see is that if you look at strength, stiffness, and impact energy, although there's some variation, obviously, what we feel is that the average fiber length is dominant in predicting the mechanical performance. So, which is in principle a good conclusion that even if there's a distribution of shorter and longer fiber, you still have can go to a predictable performance. So this is initial results, and we're looking further into this. But this is a bit of a let's say first results, which I would like to present. If we go further to the application and application technology, starting with injection molding compounds, and these are, I'll just show some examples, and maybe for you to get a feeling of what is possible, and okay, maybe get you to get some inspiration out of this, I hope. So it's injection molding compounds of highly filled fiber materials. In this case, it's a carbon fiber PPS. Really with the aim to decrease shrinkage and sink marks. So these are thick wall structures, and typically if you do that unfilled, you get some sink marks, and that's absent in these kind of materials. And that's also was a demonstration towards a larger project on a larger part of a water pump, which needed to reduce the shrinkage, and that this is it's a good material for that. So that's something we're further exploring. And also for these materials, we have data sheets available. So that's what is shown below. Also an example, and that was performed by Heron, that's on the right side of the slide, is injection molding and co-consolidation. So what they did is they made these tube from continuous fiber reinforced materials, and used some of our recycled PPS with the 40% by weight fiber loading, made it an injection molding inlay, and co-consolidated with the bar. And that's really, you can turn again production waste into parts. And it's also beneficial if you look at the design for recycling, since it's both the insert as the tube is of similar materials, so you can put this at the end of life in a shredder and reuse it again. So that's also, I think, one of the nice advantages here. Looking at additive manufacturing, so tests performed at the Thermoplastic Composite Application Center, let's say a brother of the research center, to really look at applying and focusing on small and medium enterprises, where we looked at, okay, can we print this material with high fiber content, as high as possible, and a relatively long fiber length. So this is a study is ongoing. Well, it's processable, and we'll look at further processing and testing on the way. But it's I think the first conclusion is, okay, it looks good in terms of processing. Another example is we're doing with the NLR. the Dutch Aerospace Research Center. Looking at, again, large-scale additive manufacturing, where the goal is to make a mold made by 3D printing, make thermoset parts of that, and then recycle the mold and print a new mold and see, okay, how often can we do that? What do you need for that? What is the effect of multiple cycles, etc. So that's something we're doing for the NLR, and that's a mold looking like this in a project where they are making a wing section, and the tooling for this is then made from new and recycled materials. Going from the 3D printing to compression molding, we're looking at, I said, some intermediates, which can be forged carbon type of materials, which can be used for further processing, and it's use of recycled flakes for molding applications. So this is we are doing with Weight Saver, who are located nearby in a subsidized project. And on the right-hand side is looking at, okay, can we make compounds or with very long fibers? So can we do a kind of low shear mixing, maintaining fiber length, and maintain the balance between processing robustness and feasibility and performance. So these were some application technologies. So they're more on the way, but this is something, as said, might help to inspire. Yeah, going to the summary. I think just from a generic standpoint, carbon fiber reinforced thermoplastic composites allow for really ultimate lightweight constructions, which is the main reason of using them, of course, and also the main impact on sustainability. It also allows for efficient production and for full recyclability. And especially if you look at production waste, this is well controlled and provides high quality compounds. So it's good way to start with that. End of life waste are still materials with intrinsic value, but retrieving this value really requires a dedicated and continuous effort and a cooperation in the supply chain. So what we said is, okay, let's enable this activity by starting a company which can act as a hub for the collection, making the volumes, achieving the critical volumes, so collected, format, and supply of these materials. And we feel that the combined volumes of these materials, the available technology and demonstrations, and external pressures, and it can be societal, legislative pressure, are intersecting, and I think it's a economic and ecologic sustainable activity, provided that there's a full cooperation along the value chain. And we feel it's time to implement, and we feel also that it's a joint responsibility. And with that, I would like to end this presentation. And thank you for your attention.
All right, thank you so much for that talk, Hans. That was super interesting. So we have a couple of questions in the Q&A right now. So I think we'll start with them, but if anybody else has questions, feel free to add some. I think we only have like 3 right now, but I have a bunch written down since it's a super interesting topic. So I'll just get started in terms of the order they were asked. So we have one that says, aside from specialty composites, such as those made from engineering resins and carbon fibers, do you think that the business case of recycling still holds true for materials used in higher applications, such as like polypropylene reinforced with glass fiber or nylon reinforced with glass fiber contents higher than 25%.
Yeah, that's a good question. And the honest answer is we focus on the high-end materials since there's more inherent value. Recycling of, for example, glass polypropylene is probably more expensive than buying it virgin, unless you have really huge volumes and applications. That makes it more challenging from a business case. And also we focus a bit on carbon fibers because also the ecologic business case, let's say, the footprint is much higher. So glass polypropylene, which is good, has a much lower footprint in the manufacturing part, but makes it also challenging to compete with that when recycling. So yes, it can be done. It's not so much our focus because of these reasons at this moment.
And I can answer a little bit from the automotive perspective, since I tend to work with the lower value, higher volume sort of materials at Volkswagen. And I think the business case is really going to depend on the volume at which we're recycling, especially things like polypropylene, because as you pointed out, they are so inexpensive as virgin materials. And if you don't have a well-developed supply chain, then your recycled material ends up being more expensive, especially in the qualities that you need. But I did see a paper from NREL recently that was like looking at the techno-economic analysis of the really common plastics, and recycling polypropylene should make it cheaper than virgin, but it's all about scale and the supply chain and whatnot, like you were discussing. So not a technical challenge necessarily, but a challenge nonetheless.
No, we had an unfortunate record in the Netherlands of 7 recycling companies on these household waste, let's say, went bankrupt because
oh no.
So it's a challenging arena for that's for sure.
Okay, so we have another question that says, are you recycling all thermoplastic type composites, and how effective is I think are companies like you today at separation when you have multi-material components? And I think that's referring to if there's probably multiple types of polymers in the composite.
Yes, so this is a good question, and especially with high carbon fiber loadings, that's very difficult, since the typical techniques such as infrared spectroscopy in different formats is very difficult because the carbon fiber is blocking it. Other materials, non-carbon reinforced, make that a lot more easy. Still challenging, but that's okay. So the main way of the main approach is to collect it and make sure it's separated well at the source, and do the testing afterwards, with obviously the risk if there's something wrong, you will find it out with a test, but then obviously the whole batch is waste. But that's at this moment where we are. But it's if there's any ways of separating materials with high carbon fiber content, then we're definitely interested to learn more.
Do you find right now, like looking at different end-of-life products and scraps, that you have a lot of waste streams that have multiple types of polymer with the carbon fiber? Or is it usually just one polymer with the carbon?
Yeah, production waste is typically one polymer with carbon. It's end-of-life waste is typically assemblies of different materials. And there it's indeed challenging to see, and often it's coated, so these are all challenges to to solve. Luckily, most of the materials are still in use, so the materials are have a very longevity, but we also have need some time to solve these questions.
Yeah, absolutely. Okay, so the next question is about LCA, and I think I might expand on it a little bit because I had some questions there too. So the person asks, how can the estimated emissions be almost zero in the second and subsequent recycling processes? Are there no CO2 emissions during the processing of the recycled materials? And I was wondering about essentially like how you're allocating the burden from the virgin materials as like an input to the recycling stream. And I think that's probably also what they're interested in.
Yeah, so if I interpret well, where do you take the cutoffs? Right, so if you do the second recycling, this is what this diagram shows, is the additional emissions you put into the material without further diluting. So it's really size reduction and compounding, and that's fairly low compared to the manufacturing of new materials. So that it's why it's fairly at the bottom of the graph. It's definitely not zero, but it's a pretty efficient technology.
Yeah,
and indeed,
oh, sorry.
No, yes, I just want to say indeed. So it's really a question, and that's also the discussions we have. Is where's the cutoff? Where is the avoided? Who gets the credits for the avoided emissions? And I don't think there's a real good guidelines for that at the moment.
No, I don't think so either. I was reading about the different allocation methods for when you're looking at recycled materials, and there was a guide from, I think, some university, but they described 18 different methods for allocating the burdens. So it definitely hasn't been standardized yet. And I was also going to say it might be surprising that the manufacturing processes don't have a very high carbon footprint intensity, but it's going to be very dependent on your energy source that you're using for that. And I imagine you have pretty clean energy in the Netherlands. So
yeah, and it's some of this is measured and indeed taking the European energy mix from databases, etc. But even if you compare different databases, there's differences.
yeah,
so
absolutely.
It's not an exact science issue as you might think.
No, I think that's one thing people miss with LCAs is your LCA is only as good as the data that you're putting in, and it is so hard to get good data for things like this. So
yeah, so I think it's well, how we look at it is okay, what are the order of magnitudes changes and what are the relations, and what's really impacting also in our process, what seems to have a major impact on the emissions, and that can be a focus area for our internal activities. Okay, this is something which we need to work on.
yeah, absolutely.
For example, the logistics. So we collect it now to the Netherlands, but it requires transport from different locations, and then it's let's say mathematics you have to do to see, okay, when do you have to have an extra hub somewhere, and that's depending on volumes and distances, etc. So it's a bit of getting a feeling for, okay, when does it make sense to separate hubs and be more close to the let's say the source of the waste.
Yeah, absolutely. Okay, so let's see. The next question is there an estimate of the possible kilograms per airplane of advanced thermoplastic composites that could be captured or recycled? Have you thought about the thermoset composite possibilities? So I think they're asking how much of the airplane right now is made of these materials that you're trying to get back at the end of life, if you know?
Yeah, the thermoplastic composites amount in airspace is fairly limited. So the newest aircraft are, I don't know numbers, but are predominantly thermoset materials.
Yeah.
Both looking at the Dreamliner and the 350, with small amount of thermoplastics. And that's, yeah, the question is indeed, will that increase in the future or not? But there are just looking at the production, it's already a volume which allows it, or for which it makes sense to do the recycling.
And the industries that are using these advanced thermoplastic composites are really growing, aren't they? Such as like the eVTOLs, the essentially the drone cars. I've heard that those are going to be probably made out of thermoplastic composites.
Yes, so aerospace is one, and indeed urban air mobility is definitely seen as a growth market, but also sports and leisure. So there's different places where you can use these type of composite materials, and it's also well, what we hope to achieve is that with filling this gap in the supply chain, that we can actually say together as a thermoplastic community, okay, there is a solution. So there's also solutions for thermosets, for metals. In theory, we're always claiming thermoplastic composites has a very elegant solution, but the easy question is, okay, show the implementation, and that's so let's say again, we hope by filling this gap that we can increase the business case for thermoplastics to further grow this whole market for these materials.
Yeah, absolutely. And I think it makes a lot of sense to develop the recycling techniques as you're putting the products into the industry, rather than waiting until they've hit their end of life in 20 years or something and then scrambling. So
yeah, and hopefully it's also influencing the decision-making process on which materials do we need to use to manufacture our planes or sporting goods or whatever. But say, okay, if we choose this material, then we have a solution also from a circularity point of view.
Okay, I think maybe you talked about this a little bit in your CO2 carbon footprint graph, but you have a question that asks, is there a case for using oh, actually, this is recycled polyolefin polymers with virgin fibers. I think polyolefins rather than.
Is there a case for using?
Their case for using.
Yeah, I think so. That has come back to
the
yeah, to the business case. I think, right. So
yeah, I think
in
maybe this is less relevant,
but
since you're not really working with the polyolefins, but I think in some industries there is a case for using recycled polyolefins. So
yeah, and yeah, that sounds yeah.
Okay.
So if there's a case for it, then I think that it's a very it's very nice polymer. But if we need to look at the case by case in this case.
Okay, we have a question that says, or are the recycling methods able to handle material that was manufactured out of spec? And how far out of normal can the manufacturing or recycling methods handle?
Yes, so we're looking at out of spec materials. It's a bit depending on what is out of spec. But indeed, we're looking, for example, at variations in fiber contents or components which do not meet the dimensional requirements, for example, so that can be done, or materials with a defect such as a split or whatever. So these are materials which we can indeed recycle. it's getting more difficult if, for example, the material is overheated and degraded, then it's obviously becoming much more difficult to recycle. So
is it really a matter of like the state that the polymer is in?
yeah, and in that
More than
sense,
anything else?
it is. Yeah. So fiber variations, yes, that's something we can handle. But if there's something wrong with, let's say, the polymer or maybe even the fiber, then obviously that's getting difficult.
Yeah, I was wondering if you have challenges with processing recycled PEEK and the other high temperature engineering plastics, since I think the viscosities change quite a bit once you start to add thermal histories, don't you?
Yeah, that's it's relatively stable
Okay.
in principle. So you can recycle it a couple of times. There's an end to it, and that's clear. But yeah, there are papers out there recycling 10 times is okay. It's also a bit depending on the temperature and the time and how you use it in service. But yeah, that's in principle it can be used multiple times. Yeah.
And then Raj, we have one more question. Do we have time for that? Okay, perfect. All right, so we have one question that is interesting. How close to standardization is the recycled composites market?
Yeah, how close to standardization is the composites market?
Yeah. And recycled composites.
Globally.
Yeah.
I think it's a question. Indeed, also looking at composites, it's a bit more standardization would be welcomed, and that's also going for recycled materials. And I think one topic that's related is indeed, okay, how can you collect these materials in the right way? So if you have a multi-material component, how does the dismantler know which bin needs to go, or which material needs to go in which bin? And I think if we can make some kind of standardization there, that would really help us all.
So automation,
absolutely.
robotics, all will play a big role.
Yeah, so there's different approaches to that, and yes, probably there needs to be some kind of automated to
Scale, yeah.
Scale it up.
Design for recycling. We need to be able to take those multi-component things apart.
Yeah, that's an important one, yes.
Okay, well, that was the last question in the Q&A. So, Raj, is it time to wrap up now?
Yeah, thank you so much, Cecile and Hans. It's been outstanding presentation. Thank you so much for sharing all the information, knowledge. Cecile, you're a great moderator.
Thank you.
Hans, did you have any final comment for the SAMPy community? I know you're very involved. You're a member. You're also an entrepreneur. Any comments for us?
No, thank you. I appreciate the opportunity to present a bit on our activities and thoughts on this topic. So that's much welcomed, and thank you indeed all for the attention. And yeah, let's bring this to the next step, I would say.
Great.
Yep.
Good. Okay, everyone. See you at the next SAMPy webinar or SAMPy event. Please let us know if we can ever do anything for you. Thank you, everyone.
Thanks, everyone.
Goodbye. Goodbye.